Hi and welcome to another video for Maths D Year 9. So still under the chapter of arithmetics, but today we're going to deal with squares, square roots, cubes, and cube roots. So here, usually for Maths D, you are usually required to use prime factorization as a method to find square roots and cube roots. And usually in some of the O-level exam questions, they will give you straight away in the form of prime factorization. So let's start to look at focusing on square roots first, okay? Now in here, we can use prime factorization to find the square root of a perfect square, for example, like 1, 4, 9, 25. Decimal squares can be easily found, but what happens if you have to find the value of, for example, here 484? So that's a big number. You cannot really guess straight away, but you can use prime factorization like this. So let's do the prime factorization on the sides. All right. So let's say I use the division. So let's start here. Divide by 2, so 2, 4, 2. And then divided by 2, you will get 1, 2, 1. And 1, 2, 1 can be divided by 11 because this is a factor of 11, the multiples of 11. So here you will get 2 times 2 times 11 times 11. So you can also express this as square root of index notation 2 square times 11 square. And you can separate them actually, and you will get square root of 2 square times square root of 11 square, and you will get 2 times 11. So this one, the answer for the square root of 484 is 22, right? So let's move on to the next one. Okay, apart from prime factorization, you will also encounter something like example number 2. Example number 2 here, you will have fraction mostly. Okay, so here the first one, express this as a mixed number, multiply 6 times 4 is 24, and then plus 1 will be 25 over 4. And this one, you can separate them, 25 out of 4, all of them on the square root. So here you will get 5 out of 2 or 2.5. Okay, doesn't matter which answer you choose. And as for part B, 0.0009, this one, you can express this as a fraction because decimal can be changed to fraction. But here you will have 9 over 1, 2, 3, 4. This is 9 out of 10,000, right? So leave it as this one first. And then you will notice that 9 can be square root, but 10,000 here, this is actually can be expressed as this one can be expressed as 9 over 10 power 4, right? So here 1, 2, 3, 4 because you have 4 zeros. So this one you can express this as 9 over 10 power 4. And this one, after you separate them, so 9 over square root of 10 power 4. Now notice that this one, square root of 10 power 4 is actually 10. I will do it at the side. Okay, 10 power 4. When you do the square root, this is actually 10 power 4 times half, right? So you will get 10 squared. So here 9 will become 3, and the 10 power 4 under the square root will be 10 squared. So this one can be expressed as 3 over 100, or you can make return it back to decimal. It will become 0.03. Okay, I will just leave it at this. Okay, and lastly for C, this one 12,100, and you know that 121 is square. So here I will express this as 121 times 100, and you know that 121 is a square number and 100 is a square number. You just split them like this and you will get 11 times 10. So your answer will be what? 110, right? So that's for example number 2. Okay, let's move on to example number 3. All right, this one is will be quite challenging, but here you can do it because here you are given that 1.78 under square root is 1.334 approximately, and 17.8 under square root will be 4.219 approximately, right? So evaluate this. So here usually this one will appear on paper 1, so you can use calculator when you want to find this. So this one, okay, let's do something with 0.00178. Now you have learned standard form. Okay, this one, no, not standard form. This one, you can express this as fraction here, but you have to do something with, you have to turn the number into this or this one. So let's see here. Okay, let's see if we can choose this number, because here you have to move the decimal point. 1, 2, 3. Okay, let's express this 1.78 over 1, 2, 3. 1, 0, 0, 0. Okay, so let's see over here. So this one, 1000, you cannot square root it, but 1.78 you can square root this, because this one is also equivalent, so you don't choose this. Now next one will be the next choice. Let's turn this into 17.8 by moving decimal point 1, 2, 3, 4. So here it will be 17.8 over 1, 2, 3, 4. So you have, how many zeros are there? 4. So this is going to be 17.8 over 10 power 4. And you know that previously 10 power 4, you can express this under the square root. So you will use this number, right? So under the square root, you will have 17.8 over 10 power 4. Because here, this is important. You have to express this into this one, but you do not forget that you can, you have to write also the fraction. Because here, when you turn this into this back, it is possible. So here, when you split that, okay, I will not split this up. I will just write the answer straight away. So 17.8 under square root will be 17.8 will be 4.219 over square root of 10 power 4 will be square root 10 of 2. So here 4.219 over 100, right? So when you try to express this as decimal back, 1, 2, you will have an answer for 0.04219. So this is your answer for part A. So let's move on to part B. Okay, as for part B, you will have to do the same thing with 178 also. But here, let's do, okay, let's this one have a decimal point in the end. So here, it's you have if you got the cents, you will straight away go to 1.78 over 100, because here 100 is a square number, so you can straight away use this one. 1.78 over 100 under the square root. So straight away, 1.78 is square root of 178 is 1.334, and then 100 square root is 10. So here you straight away get your answer of 0.1334, right? So that's for square root. Okay, let's proceed to the next one, when you have to encounter cube and cube root. Okay, here same idea applies, but you have to do it in terms of cube root. So here you have to use also prime factorization. So let's start with this one. Okay, 216. Okay, let's do it by division of root. Right, so here 2, okay, 108, and then another 2 will be 54, and then divided by another 2 will be 27. Now here start with 3, so 27 by 3 is 9, and 9 divided by 3 is 3, and 3 divided by 3 is 1. So here you can express this as 2 times 2 times 2 times 3 times 3 times 3. So here cube root of 216 is, okay, express this as index form, 2 power 3, okay, don't forget the 3, 2 power 3 times 3 power 3. And here under the cube root, the cube will be cancelled like the previous example. So here, okay, just illustrate this for you. Okay, split them up. So you will get 2 times 3. So the cube root of 216 will be 6. Right? So that's for this example. Right, and then next one. Here, example 4 will be quite similar to what you have done previously in example 2. So here you have to express this as an improper fraction. Cube root of 3 times 8 will be 24, plus 3 will be 27, and then over 8. So this one, when you split them up, you have to find the cube root of 27 and cube root of 8. And both of them are cube numbers. So here it will be 3 out of 2, or you can make it as a mixed number, 1.5. So that's for part A. And next one is for part B, 0.000125. So here I will just straight away turn this into a fraction. So here 125. And then here 1, 2, 3, 4, 5, 6. So this is 10 over 10 power 6. And when you try to turn this back, 125 over 10 power 6, you will get 0.000125 again. So here, split this up. Okay. It will become like this. And I will do just as a small side note, cube root of 10 power 6 is basically 10 power 6 times 1/3. So here you will get 10 power 2. So let's express this. 125, cube root of 125 is 5 over 10 power 6, and the cube root will be 10 power 2. So this is actually 5 over 100. So your answer here will be, okay, 1, 2 will be 0.05. Okay, that's for part B. And as for part C, okay, let's split this into 8 times 1000. And you can see that both of them are cube numbers, right? So here, cube root of 8 is 2. And cube root of 1000 is 10. 10 times 10 times 10 will be 1000. So this one is actually 20, right? So that's for this example. And last but not least here, okay, one example from the past year paper, November 2002, paper 1 in question 7. Expressed as the product of prime factors, 198 is 2 times 3 squared times 11, and 90 is 2 times 3 squared times 5. Okay, no need to find the prime factors anymore because you are given here. So you are going to use this result to find a, the smallest integer k, such that 198k is a perfect square. So here, what you're going to do is, on part A, not 190k, you have to compare with what happened if 198 is a perfect square. Perfect square, right? So what you're going to do is, let's have a look at 198. When you try to make it a perfect square, the lacking number is going to be, you have to multiply 2 by 2 because here you want to make it 2 square, and you have to make 11 also square. So here I will do 19 times 198, sorry, I'll just rub this off. 108k equals 2, and then here 2 square, and then you have here times 3 square. This is the original, and 11 you have to multiply another 11 to make it 11 square. So here 198, you know that this is 2 times 3 square times 11 square times k equal 2 power square times 3 square times 11 square. Notice that here, I repeat again, this one is when 198 multiplies something to make it a perfect square. So what you're going to do next is going to cancel what you see here, 2 and 2 square, so you cancel 1, 2, and then 3 square is cancelled altogether to make 1. Okay, and 11, you have to cancel 1, 11 to make it 11 square will become 11. So here, there you have it. You will have k equals 2 times 1. Okay, no need to write 1. So 2 times 1 times 11. So k is 22. Okay, so that's the smallest integer that you can find to make 198 times k a perfect square, right? You can check it yourself by your calculator. Okay, next one is B, highest common factor of 108 and 90. So here, this is your previous lesson. So you will take note that you will have to use your previous knowledge on HCF. But here you're going to use the idea of HCF. And using a prime factors here, you can see that 1 and 8. Okay, you are going to take the lowest power of the common factors here. So here you have 2, both of them have 2, and both of them have 3 square. You don't take 11 and 5 because they are not common. So HCF of this will be 2 times 3 square. So this one, 2 times 9 will be 18. Okay, so that's it for this topic. I hope that it can be understandable. So with that, thank you very much and see you again.